Good afternoon, everybody. Ready for some GIS? We'll get on in here. Let's do this. Why is my camera focusing weird? All right. Hi, Aaron. Hi, Sean. Hi, Kyle. Are you ready for the weekend? Me too. But first, we got GIS to do. Hi, Brianna. Hope you're feeling okay. I want to, hi, Alexis. So I want to tell you guys a little bit about the exam next Friday. That's right. Got an exam next Friday. So the first practicum is in the books, and I will be working on grading them over the next few days and posting your scores when I'm done with that. But your first exam, one of two, is a week from today, and it's already made. So do you want to know a little bit about it? I bet you do. It'll be, I'll give it to you via Sakai. All right, so it'll be completely, I'm working here. All right, it'll be completely online exam via Sakai, and it will be, how many questions? It's 50 points. Let me back up this a little bit. So it's 23 questions. 23 questions, a 50-minute exam, 23 questions, and all but 1 or 2 points. And there are multiple choice questions. Most of them are multiple choice. There are some fill in the blank type questions. There are 1 or 2 true false type questions. There are a few quantitative or numerical problems that you have to do. And that means you'll enter an actual number that you calculate. And then there's matching. There's a problem where you have to match. Okay? So it adds up to 50 points, and every problem is 2 points except for the matching problem. That's 6 points because there's more parts to it. All right, so that's a quick overview of the exam. It will be timed. It'll be 50 minutes. So the exam will open at 1:10 p.m. almost exactly a week from right now, and it will close at 2:10. But it's 50 minutes. It's timed. So from the time you start, you may say, well, the exam is open for an hour. Yeah, but you only have 50 minutes to take the exam. So once you start it, you have 50 minutes to finish it. It'll be remote. I'll proctor via Zoom, and this is very important. You need to have the ability to Zoom from your phone so that you can point the camera at your workspace, okay? And that means include your computer monitor. All right, I got to be able to see that. I've got to be able to monitor what you're doing. All right, that's the plan for right now. Any changes, I'll let you know on Monday. Any questions, put them in the comments. So I thought it'd be fun today to do a little bit of a free-form exploration of GIS data sets that are out there in the world for us to use. And part of this is just fun, but part of it is also supposed to be inspirational. You guys will be doing a end of semester project, which will involve you finding your own data sets to work with. So I will hopefully inspire some ideas by doing this today. All right. Is the exam open book or not? So it's not open book. It's closed book, closed notes, and it is. You got to use a computer, but you can only have the web browser open to your to Sakai while you're taking the exam. Honor code in effect here, people. We've got to be honorable, and we've got to strive to keep it that way. So yes, it will be closed book. So how to study for the exam? Well, I have that PowerPoint presentation posted on, not PowerPoint, it's Google Slides presentation. I just realized I didn't update the lessons tab with a summary of what we've done this week. I'll do that. But this collection of slides is a summary of basically all the stuff that we talked about, and I expect you to know about for the exam. All right, so that should be the review guide for the exam. All right, and there's something on there that you want to learn more about. There is probably in your textbook. It's probably in a video lesson that we've already had, or it's probably in your lab manual. So you can always, or you can just Google a search term. You want to know more about, I don't know, geodetic datum. You want to know more about, or datum. You want to know more about what that means. You can Google it. Okay, so let's switch over here to ArcGIS Pro and start to have some fun. All right. What do I got here? I got a blank project. Just started a blank map, a brand new project with a blank map. It's got the topographic base map. We'll just leave it like that for a while. And let's start exploring what kind of data is out there. So there's this button up here for add data, and we've used it before. And if you click it and go to add data to the map, the very first option here, this window pops up. Let's make it a little bigger. With these connections to portal destinations. And so what is this? Well, some of these are direct links to within your content on ArcGIS Online. Like if I click on my content, this is all the stuff that I have posted up in my ArcGIS Online account. And you can see I'm the owner, jgroff7. That's my username for ArcGIS Online. Favorites, there's nothing there. I guess I haven't favorited anything. My groups, I guess I have some, well, this is all stuff that's in my directory, in my content. My organization, this is all of your stuff. So look at all these lab practicums I'm ready to view. This is your work from yesterday. So I could open up these guys and take a look at your work. Convenient, isn't it? So one thing I discovered yesterday, this makes perfect sense. I guess it didn't really occur to me though, is that if you're saving a web map to ArcGIS Online, the name that you give it can't already be used within your organization. So some people were, more than one person yesterday was trying to use Lab Practicum or Lab Practicum 1 for the name of their web map, and they would get an error saying you can't use it. And so as long as everything is uniquely named, it's not a big deal. But let's keep looking. What else we got? So ArcGIS Online. So we're expanding the scope of the realm of content that we can find. So there's nothing here, but I could put in a search term up here. I don't know. Let's put in bears. See what we get. Well, all kinds of stuff. Grizzly bear density. Oh, that sounds cool. Grizzly bear encounters. Okay, we're gonna load that on. All right, but not yet. And then there's this other portal to a Living Atlas. Living Atlas is stuff that's curated by Esri, I think exclusively. Maybe not exclusively. There's something from NOAA. And this includes data that is data sets that are updated in, I guess you could say real time. Data that's updated frequently. So it's called a living atlas because it's living in the sense that the data isn't static. It's constantly being updated. And I think one of the things I want to show you today is in there, at least one. All right, so you have an idea of the type of data you want. This is a good place to look for it. I mean, you can go out into Google and start Googling for GIS data sets of the kind that you want, but you might as well, this tool is integrated with ArcGIS Pro, so you might as well use it if you can. All right, well, let's see. I got to look at that bears data set now. Grizzly bear encounters. Let's try that one. Let's see what we get. Ooh. Where are we? Up here north, just north of Vancouver. So it looks like, zoom to the layer. There we go. So what do we got here? Analysis, cumulative effect, forest visual quality, encounter class, backcountry, front country, high, front country, low. Let's look at the attribute table. Is there one? Yes. Encounter class number. So I don't know. There's their metadata that go around along with this. So you might not know. No metadata. It's actually, it's not uncommon to, you get data from someone else and you may not really know, well, what is this data really about? And so I'm looking at the metadata, try to get some information. There's nothing there. Look at the attribute table, see what it says. Maybe we'll look at the pop-up window. Click here. So, backcountry, encounter class. It's not really clear to me what encounter class means. Very low. An area, front country, encounter class very high. Does that mean that encounters are very likely or negative encounters are very likely? I don't know. All right, well, that was interesting. Let's remove that. All right, so as I'm doing this, there's some data sets that I found that are interesting, and we'll take a look at them, explore them. But if you have any ideas, put them in the comments for things you want me to search for. And if someone makes a suggestion that I find really interesting, we'll try that, okay? Right. So I found this data set. It's called, it's in, I'm not sure if it's in the Living Atlas or just ArcGIS Online, but it's a data set on power plants. Well, there's power plants in the U.S. That wasn't the one. Let me try Living Atlas. No. Where was this? Power plants, US EIA. No. Well, we'll try this one. Okay, power plants in the US. I'm not sure if it's the same one that I found before or not. Yeah, I think it is. So check this out. It's crazy. They should probably do some sort of in-out, in-beyond, out-beyond scaling, so you don't see all the icons when you're zoomed out a lot. But let's zoom in here. So actually, here we are. So here's Martinsburg. So this is This is dam number 4 hydro station, just up the street. Makes 1.9 megawatts of electricity. And what we got down here? Millville Hydro Station. Makes 2.4 megawatts of electricity. That's pretty small scale. Here's a Maryland Solar Power Plant, 20.9 megawatts. This looks like, what do we got here? A coal plant, 831 megawatts. Let's go up here. This is near where I grew up. I grew up in this area of Pennsylvania, just west of Lancaster, Pennsylvania. And, well, there's a wind farm here. I didn't know that. 3.2 megawatts of electricity. So this is, I think this is Bruner Island. I used to go fishing here a lot. Bruner Island. That's a coal power plant on the Susquehanna River. 1,411 megawatts, so 1.4 gigawatts. Down here in southern Lancaster County, right here, this is Peach Bottom. It's a nuclear power plant. 2.5 gigawatts of electricity, so this huge power production. So this data set has, in the attribute table, it has the kind of the primary source for the power generation: coal, natural gas, nuclear, hydro, solar, wind, and how much energy is produced, megawatts, in megawatts. So I could imagine a bunch of different projects where this type of information might be interesting, you know, like you could look at relationships between population density and proximity to certain kinds of power plants. I learned something actually right before lecture. I loaded this lesson up, and I immediately, the most famous power plant in the area where I grew up, is right here. Well, where did it disappeared? The label disappeared. Can't see that. This is 3 Mile Island, and there's a nuclear power station here, but there's no icon for it here. And I was like, what happened to 3 Mile Island? Well, I did a web search then, and they shut it down in 2019. 3 Mile Island is no more. Well, it's still there, and it's still probably very radioactive in the core, but they're not making power there anymore. All right. So, you know, it's an interesting little data set. Nobody has any ideas yet about types of data to search for? Oh, you also have the utility name. What utility company owns that that facility? Installed megawatts, total megawatts. Oh, some of these power stations have coal and natural gas at the same facility. That's interesting. Okay. So here's, you know, so one thing you might want to do is, you know, you want to do some analysis on some data that you pull down from the cloud, and you so you have this data here, the power station data, and you want to do something with it. And like maybe you want to establish a buffer around all the nuclear power stations and think about how many people live in that buffer. And there's good reason that you'd want to like have a local copy of this data. You don't want to just rely on these web layers that are out there in the cloud. And so this is interesting. If you go over here, yeah, this is a good example. So if I go over here and right click on that layer, power plants, and go down here to data, export features isn't isn't available to us. We can't export these features to our local geodatabase using this tool. In fact, it says this command is currently unavailable. The selected item is not a feature layer, or this layer item does not support the export data capability. But I bet that we can still make a local copy of this data if we use, let's use the copy feature tool. All right, so the power plants, and we'll just make a copy of it. Yep, that worked. So, I mean, the symbology changed. All of our symbology changed, but we have the data, and it's should be local now. Here it is. It's a feature class in my geodatabase. So, you know, maybe I want to do, let's see, definition query where primary source is equal to coal, apply, okay. And zoom out. Where are all the coal plants? Well, they're all over the place. And maybe we want to do a buffer where our input features are the coal power plants and, well, geez, let's call this coal plant buffer. I don't think we've used this buffer tool yet. The distance. Let's say, you know, we want to look at, you know, people that live within 20 miles of a coal power plant. And, well, we don't really have a good projection here. Dissolve, let's, nope, we don't want to dissolve. Silly me. There we go. So I used the method geodesic tool for finding these buffers, and so the buffers look like ovals. And the reason they look like ovals is because of my projection here. But a geodesic projection or geodesic model for these buffers will make sure that the distances that these buffers show us are actually real distances on the curved surfaces of the Earth. All right. All right. Well, let's delete that. Okay. Still no ideas. Nobody has any ideas today. All right. Let's look at some other. Let's get this off of here. Let's look for some other data sets. So I thought this was interesting. This was in ArcGIS Online. Somebody has together a data set on McDonald's. McDonald's locations in the US and Canada. Boom. This is all the McDonald's locations in US and Canada. What's going on right there? Look at Altoona, Pennsylvania. There's like one, two, they're like perfectly spaced out McDonald's up that corridor there. Huh. Wow, there's a lot of McDonald's. I wonder how well McDonald's locations are correlated with population. There's not many McDonald's over here in Utah. Or sorry, Nevada. There's a McDonald's in Moab. All right, so that's what. Let's see what's in the attribute table. Not much. A location, X and Y coordinates of some projected coordinate system. The name, address, and that's it. So not super interesting data set in terms of it's locationally interesting, but it doesn't have a lot. It would be interesting to know like how many customers each of these McDonald's serves. Okay, we'll remove that. Still no suggestions. Jeez. Nobody's interested in any data today. All right, well, so here's a cool one. This is in the living, yeah, right here it is. U.S. current wildfires. So this is like real-time data. And so it shows, let's see, I think there's a couple layers here. And so these are point data. This layer is point data, and it shows the location, when the fire was discovered, how many acres burned daily. Wow. Is there cumulative acres burned? Maybe not. So there's a lot of information there, and you can tell from the symbology that the size of the symbol corresponds to how many acres are burning. Acres burned, 487,000, the DOE incident out here in California. So I heard that there was a wildfire in Yellowstone this summer. Let's go see. Yep, there it is. The Lone Star fire, 4,000 acres burned. So it's kind of cool, and then so that there's actually, you have these point features, and then you have these polygons, which are showing the perimeter of the fire. So you have the point locations, and then you have polygons showing the extent. So it's kind of a cool data set. And so this is a data set that I bet you can't. Let's see, data. Yeah, so you can't export the features from here, and that makes sense. That this is this is data that is almost real time, so it's probably being updated daily. Cam wants to know, how about college locations? That is probably something that we could find. Let's check. So let's check ArcGIS Online. Colleges. Community college districts. So a lot of these look like state level data sets. KC elementary schools. Wow, you think that maybe universities. Maybe just for college locations. There's a data set called schools, national heritage areas, police stations, parks. Let's see what this one is. So this is schools in Sacramento, so it's geographically focused. Oh, here we go. So it's in the Living Atlas, colleges and universities. Let's take a look. Application has stuff. Okay, awesome. Apparently, colleges crashes my computer. Alright, let's get this off my map. Remove. So I found one. Let's try that again. It's in the Living Atlas, colleges and universities. Wow. Alright. Colleges, universities, professional schools, junior colleges, cosmetology and barber schools, other technical and trade schools. So yes, I wonder what the attribute table has in it. Name, address, city, state, type, status. Maybe the metadata has some information about what status means. GN. School population. Looks like if that's not known, there's a minus 999 there. Cool. Let's see if Shepard's in here. This is American Public University. 46,000 students. And here is Shepherd University. I'm allergic to Shepherd. Excuse me. So maybe the type or status means accredited or not accredited? I don't know. Okay, so yeah, there's data out there on colleges. Let's find some other stuff. So what else did I find that's interesting? Most of what we looked at here so far are, this is all vector data, but most of what we've seen are points or polygons. What about line data? And I thought, well, what might be out there as line data? USA railroads. So there's not, there we go. So I click on one of these railroads and what do we get? How long is this? Who does it say who owns it? Tracks owned by AO. Track owned by ELKR. So there must be different companies. Abandoned, does he get lengths? So there's not that much information here, but at least you have the locational data of where railroads are. So you might be able to like filter by abandoned railroads, and maybe so maybe a cool project. A cool project might potentially be one of the uses for abandoned railroads is to make a rail to trail project where you turn a railroad into a walking or biking trail. And there's a lot of reasons why that's a good idea, because you already have the graded right of way, and so it's easy to cut a path through the landscape if you just follow existing rail lines. Let's see. What else? Anybody else have any other things they want to look up? So there's a data set on NASCAR tracks. Um, I'm not sure why I searched for that, but I was like, I wonder what kind of esoteric things I can find. So I searched for NASCAR. Yep, there it is. NASCAR tracks. And where's the closest NASCAR track to us? Richmond? Poconos? What's that? Oh, Martinsville. So what else? So this one's kind of cool. USA airports. Here it comes. And so if we look at the layers that are in here, I'm not sure why they did this, but they actually split the data into separate layers according to size instead of just making size an attribute. Well, I think it is still an attribute in here. So arrivals, departures, enplanements, passengers, how many passengers flew through that airport. International, was it owned public or private? Military airports are in here. So what we got here? The Eastern West Virginia Regional Airport is a public airport, and it says it had 8 passengers last year. That doesn't seem right. Okay, so it's kind of a little neat, interesting data set. You get information about, airports are about connectivity. They connect people to places, and they tend to be in population centers. At least the international airports tend to be close to population centers. Could be. I was just thinking, well, what could we do with airport data? The airspace near airports is very busy, and I wonder if there's a UFO data set out there. Like people, I bet there is. UFOs. Oh, come on, really? There we go. UFO sightings in the US 2016. Wow, there's a ton of data. Let's open this up. Let's see what we got in here. So it's turning on. Yeah, we don't want, that's just too much. The black background. It's got military base boundaries on here. Oh my gosh, this is so cool. So we got a weather stations, UFO sightings. So we got this. How many are in here? Are these all 2016? Holy smokes. 5,000 UFO sightings in 2016. There's a summary. And there's a shape field. That's weird. They don't. Well, they're visualized by shape, but there's nothing in the shape field. Huh. Turn off military bases. I don't know, maybe there's a. Yeah, they don't seem to be. The shape data is missing from this data set. Oh well. Oh, how cool is that? So we got UFO data. Anyway, okay. So, there's data out there. There's so much data out there, and it's with these tools integrated into ArcGIS Pro, it's really easy to get your hands on. You can search ArcGIS online, which includes things, anything that anybody has publicly shared will be indexed there. So when you guys made your web maps and you got to put in a summary and keywords, if your intention is to share your map and have people find it, you want to have pretty accurate keywords because they're going to find it using these search tools that I've been using. And the keywords are going to be like search terms for those searches. If you're sharing data publicly, taking some time to edit the metadata and talking about what your data set is showing, what the various fields in your attribute table mean. We saw some data sets today where like the bear data, what does high versus low mean in the context of bear encounters? Does it mean lots of bear encounters, or does it mean violent bear encounters? It's not apparently clear. So anyway, hope this gets some of your creativity going, and you start thinking about what kind of data is out there, and you spend some time looking. And even before you have a project idea, maybe your project idea comes from the data, not the other way around. You find an interesting data set, you can probably find the project to go along with that data set. Anyway, let's call it a day for today, about 7 minutes early. Anybody have any questions for me before we end things here? I thought you guys did pretty good job with the practicum yesterday. That was my impression, being in there and watching you guys work. I haven't looked at your final results yet, but my impression is it went pretty well. All right, so I'm off to Tabler Farm. I'm gonna go treat my bees for Varroa mites. Let me try that again. Treat my bees for Varroa mites. Get them ready for winter. It's just around the corner already, and I'll see you guys on Monday. All right, bye-bye.